Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the unique number of occurrences problem. Given an array of integers r, return true if the number of occurrences of each value in the array is unique, or false otherwise. Okay, that's a little bit nested, but I think I understand what that's saying. So here we have 3 1s, 2 2s, and 1 3. That's an occurrences of 3, 2, and 1. Now the elements themselves are 3, 2, and 1, but that's not relevant. So each of those is unique. 3, 2, and 1, there's no double ups there. Here we have occurrences, we have 1 1 and 1 2. So the occurrences are 1 and 1. They're not unique. There's a double up there. There's more than 1 1. So we return false. Here we have 3 negative 3s, 2 zeros, 4 1s, and 1 10. So 3, 2, 4, 1. There's no repeats there. So we return true. Okay. Right. For this problem, because it's quite a good introductory problem to Leetcode, I'm not going to use things like Python's collections object. That's a bit collections module because it has a counter in it, and counter is a wee bit cheesy here. It kind of does all the work for us. So what I'm going to do is I'm going to create a new method here called frequencies. So we're going to have a dictionary, and this dictionary is going to act as our counter. For item in R, if item in items, in fact, you know what, to reduce confusion, I'm going to call this thing A. For A in R, if A is in items, items A gets incremented by 1. I have seen another one. If, however, we've not seen it before, let's just give it a count of 1 because it is the first thing we have seen. Now this gives me all of the different counts for different things. So I can return that is the frequencies of each item. So what I want to do is do f is the frequencies of the array. Okay, let's call this counts. And then what I want to do is do the count of those counts. Counts of counts is, that should not be square brackets. I don't know what happened there. Is the frequencies of, excuse the emergency vehicle going past my window. It's gone. Right. Then what we want to do is count the counts. So we have these frequencies of the different values. So now what this is the dictionary telling us how often each thing occurred. So the number of frequency, number of counts of counts is equal to len counts of counts. Unique counts of counts is the len of the set of counts of values. Whew, we're getting a bit nested here. Or it's a bit messy because we're sort of working 2 layers deep here. Return unique if the number of unique counts of counts is equal to the number of counts of counts, they must all be unique. So we used a little trick here of doing set on this object, because sets don't have duplicates by definition. If you have the set 1, 2, 3 and try and add 1 to it, you end up with a set 1, 2, 3. Now there's a motorbike. It's very noisy outside my window today. Let's see if this works, because I've got myself a little tied up in the nesting here. Frequencies is not defined because it is self.frequencies. Wrong answer. So hang on, what are the... What are the counts of counts? That's what I don't quite know. That's surprising. What are the counts? I saw 3 1s, 2 2s, and 1 1. Oh, I see. The second layer is wrong. The second layer that I'm doing here is completely wrong. So what I want to do actually is just check they're all 1. There is 1 of each count. I was getting myself so tied up in the layers there. Return all count equal C is equal to 1 for C in count of counts.items. I'm being very careful when I'm typing the counts so often. Not items, values. Pay attention, Aaron. There we go. 1 1 1. Yes, that makes sense. I saw a count of 3 once, I saw a count of 2 once, and I saw a count of 1 once. Therefore, all of the counts are 1. Right, let's use all the example test cases. Sorry, I'm just thinking ahead to how this could be simplified. That looks good. Let's submit it and see if this is accepted. It is. Excellent. So there's a bit we could do here that simplifies this a little bit. In particular, it would be using collections. So this wouldn't be self.frequency, it would be collections counter. Collections counter. And we don't need that at all. So there's some neat stuff in the Python standard library. In collections, for example, there's lots of neat things like counter and heaps, queues. No, those are in different queues or double-ended queues or decks are in collections. Default dictionaries are in collections. That's very useful. Heaps aren't. Heaps are in a different module. All is a handy little thing to remember. We could sort of nest these a bit more deeply, but I don't think that would make anything clearer. I think it would just make it shorter. So let's see if we change our runtime at all. This is already pretty quick, so I don't think we will. We got it a little bit lower, but this is so low that I suspect we're in the noise end of the scale again. Right. I think that will do me today. This is a nice little problem. The fact that you sort of have to do the same thing twice is a neat idea. It just makes you think a little bit more carefully about how you're going to structure your code. So that was one of the reasons I wanted to do it with a separate method first, because I wanted to reuse that method. It's quite easy to think that you're doing two different things, when in fact the correct view is actually I'm doing the same thing twice. Right. Do let me know how you did it, because I don't think that will be the most common way of solving this problem. So do let me know in the comments how you got on. Remember to like, comment, subscribe, all of that good stuff. And I will see you next time. Bye.